Welcome all of you to this video of Maths Made Easy. Now in this video we are going to learn about structure of atoms. Now what is there in this video actually? In this video what we get to learn is how one after the other discoveries were made, how one after the other the scientists proceeded and finally came to what we call as the present structure of an atom. Presently we say, right now what we say is there is a nucleus and which has protons and neutrons and there are electrons moving all around it. This is what we have come to know as an atom right now. Now how step by step scientists discovered this, and some scientists put forth an idea. Okay, some scientists said then an atom is like this. Now other scientists contradicted it because there were some points which it could not prove maybe. So that model of the atom was not working, and then a new scientist told something and then research was done on it. So finally we have come to know this is the structure of the atom. How it came, all that you can say the history of this discovery we are going to do in this chapter. We are basically going to learn about three scientists. One is Thompson, one is Rutherford, and then Bohr. Okay, so we are going to learn about these three scientists, what they said, one in detail. So the biggest detail is about the Rutherford's model of atom. We'll see that. So Thompson. Okay, what did Thompson say? Thompson's model. Okay, Thompson's model of an atom. What was it? Now Thompson had stated that the atom is like a watermelon. Okay, it's like a watermelon, or you can say like a pudding, or maybe you can say it's like a cake. Okay, where the entire red part of the watermelon, he said, is the positive part of the atom. Okay, that means the entire watermelon was the positive part, and the seeds of the watermelon which were in between like this, these formed the negative, these gave the negative charge to the atom. Together the red part and the seeds together made the atom electrically neutral. Okay, if there's something negative, there has to be something positive also, right, to make it electrically neutral. So together they made the atom electrically neutral. Okay, so he described it is like a mass of positive charge, and in between there are specks of negative charges which are like the seeds of the watermelon. Okay, now this was one model which was given by Thompson. Now J.J. Thompson. So Thompson also said that the total negative charge, that is from the seeds, was equal to the total positive charge that came from the red part of it. That is, the magnitude of the total negative charge was equal to the total positive charge, and so that made it electrically neutral. Okay, now let's come to the next who contradicted and he said no, the atom is like something else, is Ernest Rutherford. Okay, what did he say? Now this is the part where most of the questions come from. Okay, this is the part where most of the questions come from. What he said, he performed an experiment where he took a gold foil, very very thin, about 1000 atoms thin. Okay, that actually 1000 atoms, you should not think it is very thick. 1000 atoms gives a very thin, like you know those aluminium foils, not thinner than the aluminium foil. Also, if you have seen the silver foils that is put on sweets, something like that. Okay, so it was a very thin foil, and what he did is he started shooting helium atoms. Now not just helium atoms, doubly ionized helium atom. Now what is the meaning of doubly ionized? helium atom is supposed to have 2 electrons. Okay, helium has 2 electrons. If you snatch out both the electrons, then it becomes 2 plus. This becomes a positively charged particle. Now he started shooting these particles on to the gold foil. Now this gold foil had lots of atoms like this. Okay, it had lots and lots of atoms like this. Now what happened is, when he shot these doubly ionized helium atoms at the gold foil, there were 3 types of observation that he could see. And what were those 3 observations? Let's talk about that. Okay, so what did he see? Now few of them just passed away straight. In fact, most of them passed away straight. Okay, mostly they passed away straight through the coil. Few got deflected through an angle. Okay, they just got deflected through an angle. Few of them got deflected straight back at, okay, they got deflected straight back at a 180 degree, rebounded. Okay, so they rebounded. So 3 types: few passed away straight, few got deflected at an angle, few of them rebounded. Okay, now this helium atom has a mass of 4u and has a very high energy. Now since the energy of the helium atoms was much more than the protons there, he did not expect a large deflection. Okay. Now what conclusion did he come to after this experiment? Okay, he didn't expect the rebound, he didn't expect the deflection, because the energy of the helium atoms was much more than that of the protons in the gold foil. Now what was his conclusion? Remember, in this chapter you'll be asked questions like, what was the conclusion, what was the observation. Right now I spoke about the observation. Few mostly passed through, very few of them deflected, few rebounded. That was the observation. Now what did he conclude from this? Now since lot of them passed out straight, he said mostly empty space. Okay, he said mostly in an atom the space is empty. Okay, mostly empty space. Second, what he said is, since few rebounded, he said that the positive charges are in a very small space. They occupy a very small space in the atom. Thirdly, since few rebounded, okay, so he said that the mass is concentrated in a very small space. Means the actual mass, mostly empty space, actual mass in a very small space. Why should they rebound? Because these were positive charges. Okay, these helium atoms were positive charges, and so here in the nucleus, when they were meeting, nucleus has positive and neutral, so only when they were meeting the nucleus they were rebounding. Okay, the ones which passed through, they were not meeting the positive charges, hence they were going through. Okay, and the ones which were going through were actually, if these are the orbits, this is empty space, right? So through that they were going. The only ones which met the nucleus, they rebounded or they deflected. Now what was the inference from this? Every scientist will come to an inference. Okay, finally, you know what inference is? Finally what they say, you know, finally what, after conclusion also, finally what idea he got about that he is going to say. So finally he said positive charges are in the nucleus of the atom. That he found out because it was rebounding from there. Okay, secondly he said electrons revolve in circular paths. Thirdly, his third inference was size of the nucleus is very small. Okay, size of the nucleus is very small compared to the size of the atom. That is why so many passed through straight, right? Now what was the drawback? Okay, what was the drawback? Though he was quite close to the present model of the atom, what was the drawbacks of Rutherford's model? Rutherford had told that the electrons are moving around, revolving around the nucleus. Now it was told that anything which is moving in circular orbits, okay, accelerate. Because anything moving in circular orbit, there is a changing velocity, and change in velocity means there is an acceleration, and anything that accelerates will radiate energy. Now something which is constantly moving around the nucleus and radiating energy, a time will come when the energy will get over and that electron will collapse into the nucleus. But everything around us is steady. Substances around us which have electrons, protons, neutrons, they are not collapsing. They are not at all collapsing. They are all steady. Then how can we say they are radiating energy? Okay, so this was the drawback, and if they are not radiating energy, how are they moving in circular orbits? So this was what was told as a drawback of Rutherford's model. I repeat, since it was moving in circular orbits means it is accelerating. Accelerating body radiate energy. If it radiates energy, it will at one point of time fall into the nucleus and everything around us will collapse, which is not happening. Therefore, there is a drawback in this model. That is what again scientists said. Okay, now how did he overcome this drawback? Now Niels Bohr, who was another scientist at that time, he said that what Rutherford said is correct. Okay, why he said it is correct? Because he said if anything, here the electrons are moving in discrete orbits, means fixed orbits. Okay, the orbits are fixed. They are not moving anywhere and everywhere. Okay, they are moving in fixed orbits at fixed distances from the, so they are moving in fixed orbits. Second thing, if they are moving in discrete orbits, they don't radiate energy, and therefore the question of collapsing does not arise. So that is why Niels Bohr said that his model is correct. They are moving in discrete orbits, and things moving in discrete orbits will not radiate energy. So Niels Bohr said is, he told that the atom looks like this, where at the center we have the nucleus, okay, and then this is the K shell innermost, then we have the L shell, then we have the M shell, another shell will be called the then we have the M shell, another shell will be called the N shell, like that. And the formula which dictates the maximum number of electrons in a shell is 2n square, where n is the number of the orbit. Means in the first shell, 2 into 1 square, which is 2 electrons in this, okay, can be maximum. Here 2 into 2 square, that is 8 maximum can be there in this shell, and 18, 2 into 3 square, 18 can be there in the third shell. Now James Chadwick, not much is there in your syllabus from this, that is the discovery of a neutron. So neutron was discovered by J. Chadwick. Now how he discovered, what proof he had given is not in the scope of your syllabus. Now till now everybody was talking about only electrons and protons. In the nucleus it is positive. They didn't talk about neutrons. Okay, now James Chadwick said no, there is one more subatomic particle with the proton inside the nucleus, which is called a neutron. He said mass of a neutron is equal to mass of a proton. Okay, what he also said is mass of an atom therefore is equal to the sum of the masses of the neutrons and the protons okay. So, and neutrons do not have any charges. Okay, so after this comes electronic configuration. Okay, so please check my video for electronic configuration also, you will get it in the playlist. So that was it from structure of atoms. This is how atoms finally got their final present structure. Okay, if you have liked the video, do not forget to like, share and subscribe. Also leave a comment behind if you are liking my videos, and do not forget to see the playlist for more videos. Okay then, thanks for watching. Bye then.